Okay. So this is my presentation, Poison in Paradise, by me, Jason Johnson. It began on a rainy October day. That day there was a National Honor Society meeting. And during lunch, I wasn't expecting a ton to come out of it, but I volunteered for Nature Consortium anyways. And they work to help restore local parks and green belts. We got a lot done. Such as clearing out invasive species, planting native plants, helping lower pollution, and feed native animals. A week later, I was still volunteering for Nature Consortium, even though all of my friends were gone. At this point, I was understanding the purpose of the work. I was understanding that I could have volunteered for anything, but I chose to do that because of what I saw. I saw barren forests, bush litter where leaves should be on the ground, and shopping carts where bushes could be. Following this path, I decided to work more in nature. Following that instinct, I did a salmon watch on Longfellow Creek, and there's a picture of me doing that. This is not your standard salmon watch, and the first night, it was an intense salmon watch that required a lot of time. The first night I attended an interesting lecture. About the effects of stormwater pollution on salmon. Did you know that in Longfellow Creek, they have a 60% pre-spawn mortality rate, or salmon that die before they spawn? That is 59% higher than it should be in the wild. That is because of stormwater pollution. We also heard about how much the salmon are affected by stormwater. It gets into their system and they suffocate because of an unknown chemical. And I think that's really, really a tragedy. You know, these are beautiful animals and they do not deserve to die in such a way. Every week for the survey, I walked in Longfellow Creek and waders looking for living and dead salmon. If they're alive, I took a picture or recorded a video. If I found a dead one, I'd cut it open and see if it has eggs or not. Then I recorded the data. The results with all the other teams were compiled, giving us a clear presentation on the creek. The next kind of stage of my awakening came in marine science class, where we watched a film called Poisoned Waters. Poisoned Waters showed me a lot of really important things, some really tragic things about the effects of stormwater pollution and how that was draining our community, and about how the effects of pollution on many animals, including frogs with 6 legs. Over there. Now, the most tragic thing I saw was the death of our Puget Sound orcas in our very waters. When I was young, the first stuffed animal I ever had was a stuffed orca. But partially because of this, I have loved these whales and their environment for my entire life. And I think at this rate, in 30 years, we won't see them anymore. While volunteering with Puget Soundkeeper, which is a nonprofit organization whose mission is to save the Puget Sound, I went on a tour of the Duwamish River. And on this tour, I asked the guide, how does our river continue to be polluted? Aren't we doing better? She responded that stormwater pollution, that better is a relative term, and ships are still actually allowed to dump sewage into Puget Sound, and we are still allowed, PCB contamination is still there, which is a horrible death sentence for these orcas and other marine life. Finally, the people of Seattle just don't seem to care very much about the impacts of their decisions, their everyday decisions. This showed me how great this problem is, and it filled me with determination to fight to keep our beautiful Puget Sound alive in Seattle and across all of Washington. I believe that if you want to make a difference in something, you have to be the one to make the sacrifices and try to make the difference yourself if you expect anyone to try to make the difference with you. And all this led me to my question. What can we, as the citizens of Seattle, do to protect our local rivers, streams, and waterways? If we are going to save these animals, we must address the problems of the dangers of pollution, such as stormwater runoff, the loss of habitat these animals are experiencing, and the problems of biological diversity loss in Puget Sound. I would also like to discuss how these issues are connected to one another and how each of them work together to bring these animals towards extinction. For each question, I will argue specific solutions. Traditional water pollution is a big problem. So traditional water pollution will be defined as pollution coming from a single identifiable source, such as a pipe or a drain. Types of pollution in Seattle are mostly legacy pollutants. And legacy pollutants are things that are illegal to dump into Puget Sound now, but continue to still be present as they don't degrade. These are things like PCBs, arsenic, lead, and mercury. Now, a question I get often is, what is a PCB? PCB, or polychlorinated biphenyl, is a chemical once used as a coolant or lubricant in a lot of electronic equipment because it doesn't burn easily, and it doesn't degrade. It was banned by Congress in the 1970s because it causes cancer and infertility in humans. It can also include other types of pollution such as wastewater pollution, sewage. Finally, it can include trash. A major concern is what is wastewater pollution, which causes health problems in fish and humans if humans choose to swim in it. So some effects these chemicals have on wildlife is they all combine to kill salmon, such as arsenic, mercury, and lead can lead to poisoning in the short term, and in the long term, they can all cause brain damage. They can also do this in orcas. And orcas are the most PCB and mercury infected animals in the world. And PCBs are highest in the Duwamish River, and they were dumped there mostly by Boeing in the 40s. Wastewater can cause algae blooms, which choke out all the oxygen that these marine mammals need to live. They can also produce toxic chemicals, which can kill fish in the thousands. All of this can lead to, wastewater can also lead to microbial growth, such as bacteria, which can kill thousands of fish and even humans if a human chooses to swim in it. The combination of toxic algae and these oxygen-starved conditions cause dead zones, which are zones with no oxygen or life in the water. Another dangerous side effect of these algae blooms is that the toxins accumulate in shellfish. And humans sometimes, when they eat this shellfish, can actually be paralyzed or killed from the sheer concentration of toxin in these shellfish. What we can do to help. The Trump administration has talked about serious cuts to the EPA. Well, the Duwamish site is still infected with PCBs. We need to continue cleanup efforts. Right now, we haven't even reached the industrial goal of 15 parts per million of PCBs. Many in the South Park community have argued that it should go down to 1 PCB, or part per million. And I agree that this is the only correct course of action and that we need to pressure the Trump administration to allow the EPA to clean it to that level. We also have to restrict black water, which is sewage dumped from ships, from being dumped west of the San Juans. Why I say this is because many think Puget Sound operates like a toilet. Well, really, it's more of a bathtub, where sewage, where whatever we dump into Puget Sound is not just flushed out into the ocean, but it in fact stays in Puget Sound for many years, like a bathtub, before it ever reaches the ocean. It's important that we restrict where landfills are made on the Puget Sound and put stronger limits on barges. Something that I've personally seen on that Duwamish tour is a junkyard lifting up junk off of their site and placing it on a barge. And I saw all this metal and oil falling into the water, and I think that's really terrible. I think that's just deplorable, and we need to stop that. Another way is to help restore beaches to their natural state, meaning restore the wildlife and vegetation that used to live there, and prevent building on some beaches, which is very hard because of people want to live on beaches. But either way, we must make zoning laws stricter to not allow them to. Another major problem we face is PCBs and arsenic and lead. We don't really know how to dispose of that. PCBs, we know, when heated up to 1,000 degrees Celsius, can degrade, but that isn't always an exact formula. They just weaken, but sometimes, if the right conditions happen, they can form an even more toxic substance. And we just need to know how to degrade some of these materials more easily.